In the last section, we started wondering why we would use streams at all. To answer that question, we put together this little game where we have to click a button nonstop, and as soon as we stop clicking it for at least 1 second, our console prints a message that says that we lost. Now, building this game using normal code and not using streams would have been far more complicated, but maybe that's not a good enough reason. So let's take a look at a couple of different diagrams that are going to explain to you exactly why using streams in this case is so advantageous. Okay, so with the first example we looked at with the chocolate cake factory, you and I manually created a sync, and we hooked that sync up to our stream through that stream controller. So in that case, we were manually creating events and pushing them into that stream. Because we were manually creating those events, it didn't really seem like there was a lot of benefit to this. But the thing to understand here is that there are a lot of cases inside of Dart Flutter and Dart where that sync or that source of events is going to be provided by Flutter or by Dart, not by you and me. So there's many different opportunities or many different locations where we will be getting sources of information from Dart and Flutter that represent user input or some input from other source of information, and you and I interface with that source of data through a stream. And so a perfect example of that is this button right here that we just worked with. So in this example, we created the HTML button over here on the HTML tab. We then got a reference to the button, and then we referenced button.onClick. .onClick right here, you can click on it, like the actual word on click, and then if you look at the bottom right-hand side, you'll notice that this thing is called an element stream. Keyword there being stream, of course. So this is an example of one place inside of Dart where we are interacting with Dart, or interacting with this button element through a stream. Every time a user clicks on that button, this stream right here is going to emit a new event or a new little piece of data. And the only good way that you and I have to work with that click event is through the stream that Dart creates for us. So that's a good example of why we care about these streams at all. It's a prime way in which we interact with Dart and Flutter. We're not only limited to working with those button elements. Another example of where Dart would provide a stream for us would be if we created an HTML input. A user typing into that input triggers change events on that HTML input. And so Dart, again, provides us with a stream. Every event inside that stream describes a user typing something in. And so you and I might take that source of events, we might set up some processing step where we look at the input or the value inside the input, and then we produce some validation message out of that. Another example of why we would want to use a stream would be, okay, well, series of buttons. That's pretty much what we're doing right now. One last one. Here we go. This is a good one. So another place where we might want to use a stream is when we create network requests. Now, we already created a network request before, and we got back a future from that, which remember is like a JavaScript promise. But we can also interact with network requests by treating them as though they were a stream that emits events like, say, a successful fetch of some data or an error message that might occur while we are fetching some data. And then inside the stream that you and I set up, we can add in little map functions or little transformers that take the data that we get back from the network request, parses it, turns it into a model instance, and that gives us back some parsed JSON data. Okay, so clearly making use of streams is definitely advantageous because there's many locations in Dart and Flutter where that is just the mechanism that we have, the sole mechanism we have of interacting with information that Dart is giving to us. But maybe that's still not a good enough reason to you. Maybe you're still thinking, Stephen, why would we care about that, right? Like, okay, Dart saying this is the only way we can interact with that? Why? All right, so let me give you another example. Let's take a look at the application that we actually built right here. So in this application, like I said, we're watching this on-click stream, which is our source of events, and we chain onto that something called timeout right here. Now, if you click on timeout, you could definitely read the documentation on it down here on the bottom right, but I'll just show you a diagram to give you a better idea of what .timeout is doing for us. So first, notice that we're passing in a duration object right here that has 1 second tied to it. So let's talk about what this timeout thing is doing for us. Okay, so inside this diagram, we have kind of a time series of events or a time series of clicks on that button. So everything starts over here at 0 seconds. So this is like when we first load our application up. And then we start clicking on that button. And so every box along here represents one button click. And so I was clicking pretty darn fast. Like I was click, 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 click. And that is represented by every one of these boxes that you see on here. So in the first 3 seconds, I was clicking nonstop. So what that timeout thing does for us, back here, what this timeout thing right here does for us is it waits for 1 second to pass, and specifically 1 second because we passed in a duration here of 1 second. It waits for 1 second to pass without any event occurring. And if that happens, if we go for 1 second without any event, then this timeout thing right here is going to call this onTimeout function. And so inside the onTimeout function, you and I reference our sync, and we add an error in to say, hey, you lost the game. And that eventually went down to our listen function right here, which is where we pick up data that's coming through our stream, and we took that error and printed it out. So this example right here is another good reason of why we like to use streams. Building something like this with normal kind of procedural code, where we might put together like a for loop or something like that, would be exceptionally challenging. Maybe not exceptionally challenging, but definitely not the easiest thing in the world. When we implement this using streams, the code for it is rather concise and pretty easy to read. But if we tried to implement this with just classic procedural code without using streams, it would without a doubt be far more complicated. Okay, so let's sum up here really quick. Why do we like to use streams? Why is it so important to us? So first off, we like to use streams because a lot of pieces of functionality inside of Dart and Flutter will return streams that you and I have to work with. So we're going to interact with those streams to essentially receive data from standard library modules as a part of Dart and Flutter. We also really like streams because we can compose that processing pipeline out of easily reusable functions. And so in this particular example, well, we're not seeing anything too useful here, but at least back with the cake stream that we had previously, here's the cake example right here, we put together that stream transformer here to represent our baker. If we had other steps in some other stream where we had to check to see if a cake was of type chocolate, we could very easily reuse this stream transformer right here. In this case, we had just taken the baker, which was the stream transformer, and we passed it into that transform function. And so everything that we do around streams tends to be very easily reusable. Third, pretty darn easy to read the code that we write for streams and understand how they modify data. Now, the example I just pasted in here kind of reformatted everything, but if we very quickly reformat it, you'll notice that it tends to be pretty easy to kind of just read this from top to bottom and get a good idea of what's going on. So we're taking our source of data right here. We are pulling off the type property. We're passing that data to the transform of baker, and then we do something with the output. If we try to write the same thing or try to write our button example with some normal code, it would probably be far more complicated to read, a lot more challenging to understand. Now, the fourth item on here, this is where streams really go above and beyond not using streams. So streams are all about some asynchronous series of data, like a series of button clicks from a user. We don't really know when those clicks are going to occur. If we ever have to do anything related to time, or related to like timing a user clicking on something or pressing something, always a million billion times easier to do these time-related operations with streams than without them. Again, I kind of challenge you to write out this example without using streams at all, and I think you'll find that it's kind of complicated, or at least a little bit tricky. Okay, so that's kind of my case on why we're using streams here. I don't know, maybe you're convinced, maybe you're not. I think that we still could stand to get a little bit more practice though, so let's take one more pause and we'll look at another example or two of using streams inside of Dartpad, and we'll finally go back over to Flutter and start working with our block pattern using these streams. So quick break and I'll see you in just a minute.